All right, so let's start. Just quickly go over the problem we did last time. So last time we covered the how to use the it's a geometrical construction. So basically, we have two things. We can use the ruler and sometimes some people call the straight edge, right? The ruler and the compass to draw all different kind of stuff, right? There's something that we can do, and certainly there are also something that we cannot do. Okay, but we only focus on something that we can do. So we can do the following things. The first thing is that we can do the angle bisector, right? We can do the angle bisector. How can we do this? Let's take a quick look. So I can first of all, suppose you give me angle like AOB, right? The angle. How could I draw angle bisector? First, I'm going to draw a circle in this way, so that a circle with any radius, but the center is at the O, so that I can intersect the two edges at the points A and B. So A and B are the points, right, with the same distance to the O, but on the two different sides. And now I'm going to go from A with the center at A and draw a circle. And I do the same thing with the other center of B. The two circles, the two red circles intersect at the 2 points. But I just pick one of them. Let's pick the C here. And I connect the OC, actually make an extension, and that is the angle bisector. How to prove this? It's very easy to prove this because if you look at the two triangles, right? One triangle is a OBC. The other triangle is OAC, right? The two triangles, all of the three corresponding sides, right? All of the pairs of the corresponding sides, they are the same. They're congruent, right? Okay, so that's for the angle bisector. And the next one is for the perpendicular, right? Perpendicular line. How to draw the perpendicular line to a given line? And then we have two sub questions. One is you want to draw a perpendicular line to a given point on the line. So P is on the line, right? How can we do that? Basically, this is just like you draw the perpendicular bisector, right? Perpendicular bisector. It's just like that. So you first of all you can go from with your circle with the center at P, right? And with any radius, you can make a circle, and that circle intersect the straight line at A and B, right? And then it's just like you are doing the angle bisector. So here you get the angle of APB, and you want to draw angle bisector, right? How can we do that? Just like the previous one. So the angle bisector of 180 degrees is just 90 degrees. Okay. All right. So next one. Okay. So next one. Let's see. Suppose P is not on the line. Okay, suppose P is not on the line. So what does that mean? Well, if P is not on the line, then you're going to get AB, but you're still going to use a circle center at P, and then you intersect the original line at A and B, and then you do the same thing. So basically, it's quite similar with the previous one. Okay, and next one, how to draw the perpendicular bisector? Same thing, right? Same idea. Okay. And then we go to the tangent line to the circle. Okay. So let's think of that. How to get the tangent line to a circle? How to get the tangent line to a circle? Right? How to do that? Let's think of that. So the basic idea is that where we need to use the theorem that we introduced earlier, right? If I have a perpendicular line to a circle, then OA the perpendicular line if and only if OA and AB, right? If and only if, so they are actually they are actually perpendicular. So basically, I just need to draw a perpendicular line to the radius, right? And from the point of right from that point of A, and then you can do that, then, right? Okay. Let's see, next one. Here's another one. That's from last time. Second question. So what happens if A is outside of the circle? Okay, if A is outside of the circle, what do you do? Where if A is outside the circle, and we know that I need to have a point P here, so that OP is perpendicular with AP. All right, so that's the key idea. So that's the main idea here, right? We started we stopped at that point here. So how could I get the point P, right? But I want the P where P is a tangent point if and only if OP is perpendicular to AP. But where can I get? How can I get that that P point? Right, P point must be on the circle, but P point must perform a right angle to O and to A. Right? How can we do that? Well, so here's the idea. So we can just write that here. The idea is that I'm going to construct a circle. So if I can get a circle with OA as the diameter, okay, so the radius circle here. All I want is that I want to construct a circle so that OA is the diameter of the circle. Then this circle intersects the original circle at P. And I claim that P must form a right angle with O and A. Right? Why? Well, that's just the theorem we did earlier, right? So as long as we get the diameter, and then we can always have the right triangle, right? Have the right triangle. So that's always true, right? Everything's okay. How to prove that? We prove this by using the inscribed angle theorem, right? Because the inscribed angle is half of the curve, half of the arc, right? That arc is half of the perimeter, half of the circle. That's 180 degrees. So 180 degrees divided by 2, that's 90 degrees. So that's how we can get that. So the question here is that how do you get such a circle with OA as a diameter? And that's easy. How could I get that? So I can first find, so step one, I'm going to find the midpoint of OA. So let me call the midpoint of B. So B is the midpoint of OA. How to find the midpoint? We did that last time, right? We just finished that. We say it's a perpendicular bisector, right? So we can draw the perpendicular bisector of OA and we can get the midpoint. And after we get the midpoint of B, then we can just draw a circle, right? With a center at the B and with the radius of OB, right? Because B is the center of the circle, right? So I draw from with the B at the center and OB as the radius, and then I can draw a circle with OA as the diameter, right? And suppose this intersect at the P, and then we are done, right? So P is the intersect point. P is the intersection point, right, of the two circles, and then we are done, right? Just connect the OP and AP, and AP must be the if that's the case, then, right, if that's the case, then OP is perpendicular with the AP, and this implies that AP is the tangent, right? Is a tangent, right? You can get another one. AP is a tangent line. All right, so that's from last time. Are there any questions? So I've just finished this. Everyone's good? Very good. So someone asked me to explain question number 7 on homework 4. Okay, let's do it. Let's try that. Okay, so let's do the homework for question number 7. Okay, well, so first of all, the first question should be easy, right? So how could I get so you know the picture here. Let me quickly draw the picture. Okay, so I can get this circle here, right? And then I have something like that, something like this way. Right. So the first question is that how could I get the angle P? Where according to the rule, right? So this is 1/2 of xy minus the wz, right? So that gives me 1/2 of xy. What's xy? I need to look at that. Xy is 105 degree and minus wz. Wz is 25 degree, and then we are done for that, right? The other one, the angle of xqy. That's in a similar way. That's just the xy and then plus the wz, right? And then you do the same thing. So that's for the part A. How about the part B? Part B is tricky. So I give you x, w, z. So x, where's the xwz? Xwz. Okay, so xwz. Let me use the red one. So I give you this part, this arc here, right? So this arc is 128 degrees. And then I have another one, another arc. Let's see, it's a y, x, and w. This is 220 degrees. So where is that? Let me use this. So y, x, and w. So I get that one. Right, so that's a green arc, okay? And then I'm looking for the P here. So let's see. I'm looking for the angle P. Well, first of all, angle P is just the XY, right? And then minus the WZ here. Does it make sense? So that's just the previous one. Okay, but now I'm gonna add a common thing here. Okay, I'm going to add a common thing. That is, I'm going to add a xy, and then I'm going to add a xw, and then subtract the xw. Can you see that? So you got you add a xw, you subtract the xw, right? And so what is this? This is just 1/2. This is just the first one is the is a yxw, yxw, right? That's the first one, right? That one goes here. And minus the other one. What's the other one? The other one will be wz and the wx. So that will be the xwz, and we get that. So it's 1/2 of 220 degrees minus 128 degrees, and we can get the answer. Right. Part C is a similar way. It's quite similar with that. So basically, you add something and subtract something. Right. Okay. Okay. So that's a homework problem. Let's see. What do we do today? Okay. Well, today we will continue the geometrical construction. So it's the second part of the geometrical construction. Okay. Now, so last time, remember, last time we draw so what we did last time? We draw, so last time this question here asked us how to draw a tangent line to a circle from a point outside the circle. Okay, now I'm going to ask you a different question, so but related. So here is the problem. Suppose I give you two circles. Okay, so let's say given two non-intersecting circles, okay, with let's say different radii. Okay, and then I'm going to construct a line, construct a tangent line, a line tangent to both circles. Okay. All right. So I want to construct. So suppose we have two circles of the different radian, and I want to construct a tangent line for both circles. Okay. So there are many different ways, and there are some different ways to do that. Okay. We're going to do that one by one. Okay. So first of all, let's say suppose we have two of this. So let's see. I'm going to get the. Let's say we get a bigger one, and then we get a small one, right? We get two circles, right? And then I want to get the tangent line, okay, tangent to both of the circles. All right. So first of all, can you tell me how many such a tangent line are there? If I have two circles, right, they are not intersecting. How many tangent lines are there? So first, how many tangent lines? Okay, first, how many tangent lines to both circles? And how many tangent lines to both circles are there? Okay, I want to draw the tangent line, which is tangent to both circles. How many tangent lines can you draw? Okay, can you answer the question? Anyone answer the question? Well, you can just look at that. Just first of all, you don't have to draw that. Just take a look. How many such tangent lines are there, which are tangent to both circles at the same time? Okay, someone says two, or someone say one, or two, or three, or four. Okay, well, I can show you that. Let's see. First, maybe you can do this. So here is one way you can do, right? And then by symmetry, you can do the other way like that, right? Are there any other tangent lines where you can say, can I do a different tangent line? Is there any other tangent line that you can draw? Uh, well, we can do that later. So let's say, let me just do the two of them. Okay. So we can actually have other tools, but let's just do that right now. Okay. So for the suppose I want a tangent line such that the two circles are in the same side of that tangent line. Okay. So let me call that this is O, and this is O prime. Okay. And then the radians for the first one, I can get the R1, and then I can get the R2 from the other side. So this is the R2 here, and this is the R1 here, right? This is R1 here. Okay. And if I connect the O1, O and O prime, I can have that. All right. So first of all, let me ask you the question here. So you get an X here, you get a Y here. Right. So what kind of shape it is? I'm going to go give you the O prime, and the Y and X. Okay. So this is the quadrilateral. So what kind of quadrilateral are there? It's a trapezoid. Why is a trapezoid? It's actually a right trapezoid. Why it's a right trapezoid? Because of the theorem we did earlier. This has to be a perpendicular. This has to be a perpendicular. So this is a trapezoid. It's a right trapezoid. Does it make sense? So this is a right trapezoid. Trapezoid, something like that, right? Does it make sense? So these are right trapezoids. So the question here is, how could I construct such a right trapezoid? How could I find the X and Y? Okay, think of that for 30 seconds. How could I do that? All right, so what can we do here? So here we can try the following. Okay, the first thing is that I just try to do the following. So let me just draw from O. I want to get a right angle here. So that's a right triangle, right? So basically, what I can do here is that I want to find a P, right? This is a P here, right? And so let's see. So uh, basically, this is R2 and this is R1 minus the R2 here. Okay. And the important thing is that I want to get the P, right? So the idea is that I want to construct. So maybe I should say I want to get the point P. Okay. I want to get the point P. Okay. Such that the OP is R1 minus R2. Okay. And the angle of OPO prime is 90 degrees. So that's the two conditions I want. Okay. So the important thing is that I want to find a P here. How would I find that P? Well, I'm going to show you later. But that P should have the following two conditions. The OP should be R1 minus R2, should be the difference of the two radian. Okay, and on the other hand, the angle here must be a right angle. How can I do that? Yes, you can do it. Right. So to do it, you can first draw the. So let me do it. First of all, you are going to draw a circle. So first of all, you are going to draw a circle with radians. So this is a circle, right? So that means you're going to draw a circle with radians, R1 minus R2. Can you see that? You get a circle with radians R1 minus R2. And secondly, you are going to draw another circle with O and O prime as a diameter. Okay, and we did that last time, right? So secondly, you're going to do the following. So the basic idea is that you're going to get the center, the midpoint here, right? So this is the midpoint, right? And then using this midpoint, you can draw the circle, something like that. I tried my best. So I'm not good at drawing, but something like this. Right. So this is a circle with a diameter of O and O prime. And then the two circles intersect at the P, right? The two center intersect at P. So that's my intersection point. So that is an intersection point, right? So they intersect. So the red circle and the green circle, they intersect at the point P. And then we are done. Okay. So after you find the P, and then we can make an extension. Can you see that? So as long as you can find the P, you can find the X, right? So make an extension of OP. So extend OP and to intersect the original circle of O at the point of X. And after you get the point of X, you can get the point of Y by drawing the parallel line, right? Or you can draw the perpendicular line. That's okay, right? So does it make sense? So I didn't write down all of the steps, all of the details, but just show you the idea. Okay, give everyone one more minute. So what does that mean? So what's the rule here? You try to assume X and Y is are the tangent points. So XY should be perpendicular to the two radians, right? So we get that the quadrilateral to be right trapezoid. Okay, how do I get x and y, where it's just decided by the point P here. So I'm going to shift the x, y to the P and O prime here. So if I can get the P here, then I can get the x, right? How could I get the P? Where P is the intersection of the two circles. One is with the radius of R1 minus R2. That's the red circle. The other circle is a green circle, right? Why do I want to do that? Because the green circle makes sure that the angle can form a right triangle, can form a right angle. The red circle makes sure that the OP is equal to R1 minus R2, right? Okay. Everyone is good? But this is just half of the solution. Why is it half of the solution? Because we have other ways to draw the tangent. Okay, so that's just one of the solutions, but you have some other solutions. Okay, what's the other solution? So here is the, let me give you the idea. Okay, here's another way you can do it. So suppose that you're going to have, okay, it's a little bit tedious, but it's quite similar with the, so I'm going to draw again, let's see. All right, suppose this is a big one, and then I get a small one here. And can anyone tell me how to draw another tangent line? Any other way to draw a different tangent line? Well, you could have a different tangent line. How? You could have a tangent line in this way. So you have that, it's a tangent line. Can you see that? This is a tangent line, okay? And certainly you can do, by symmetry, you can do another way like this, right? But by just because of they're similar, so I only do one of this, so I don't do the other one. Okay, just do a, just try to do a one of this. Okay, where let's see, let's do the other one here. I want to do okay, so I want to do okay. Let's say suppose I only draw that's tangent line. Okay, this tangent line so that the two circles are in the opposite side of the line. So what can I do here? Let's think of that for 20 seconds. Well, so this one says you're going to do, so let me again, I'm going to get the center O and center O prime. Okay, so let's say, let's draw this, and then we can get the following, right? So let's see, wait a second. I think something was wrong here. What happened here? Okay, good. All right, so let's see. So here is what we are going to do. Let's see, we get that, and we get this one here. All right. And again, this is a right angle, and this is a right angle. Okay, so the question here is that this is O prime, and this is the X number, this is the X point and the Y point. And again, how do I get the XY? How do I get that X and Y? That's a hard one. Okay, this is hard. How to do this? Well, let's make it's actually similar to what we did earlier, like that. So I want to shift the XY so that the one point is at the O prime. The Y becomes the O prime. and x becomes the p. So that's the idea. I want to do it. Okay, so let's see. What can I do here? Where I'm going to shift I'm going to shift it in the following way. So basically, I'm going to do here, make extension, and then you go from there, and then goes that one here. And this is my P. All right, I'm almost down here. So basically, what you can do here is that you want to find, the idea is that you want to find the point P such that your OP is R1 plus your R2. So this is your R1 and this is your R2. Can you see that? So that's the R2 here. So R1 and R2, right? So the radiance is the R1 plus R2. And then the other condition is that I want the angle of OP, O prime, that's equal to the 90 degree. So I just need the two conditions. And the two conditions can be done very easily. Why it's very easy? The first one is that I can just draw a circle with the radius of R1 plus R2. Okay, so the first one will be like that. Like this, right? That's a circle. We don't have to do the whole thing, but you just guess here, right? So this is a circle of radius R1 plus the R2. Okay, that's a red circle. And then I'm going to draw the green circle. What's a green circle? It's similar to the above. I want to draw a circle with O and O prime as a diameter. So the green circle will be something like here, right? Like right. So this is a circle with O and O prime as the diameter. And then we are done, right? The two circles intersect at the P, right? And after that, I'm going to connect the OP and intersect the point X, right? So after I get the point X, then I can get the point Y by doing the perpendicular line. Okay, again, I don't want to give the much details, so so that's just the idea. Okay. Any question? Okay. Anyway, so let me summarize a little bit here. So if I get two non-intersecting circles, how many tangent lines are there? The answer is 4. Does it make sense? So you get 4 tangent lines, right? We get 4 tangent lines. But on the other hand, what happens if the two circles are intersecting? So let's see. What happens if we have? So here is a similar question. So what if? Let's see. What if circle O and circle O prime are intersecting? What happens if they're intersecting circles? Well, so the problem becomes the following. So you're going to get here's one circle like that and another smaller circle like this. So how many tangent lines are there? First of all, just 2, right? Just the first type. So in this case, the number of tangent line is equal to 2, right? You only have the first type. You don't have the other type. And now how to construct that? It's similar to the above. And so construction is similar, okay, to the above. Okay, why it's similar? So you can actually do the similar thing. So I'm going to get that one here, right? This is my center, and this is my center here, right? And so I'm going to connect that. So this is O, and this is O prime. This is X, and this is Y. Okay, how could I finish the construction? I want to find X and Y. I want to find the intersection. And if they're the same as before, just like the picture, right? The previous construction is still working. It doesn't matter the two circles are intersecting or not intersecting, right? It's the same idea. right? So basically, you're going to find such a P, right? You're going to find such a P so that this is R2, this is R2, and this is just the R1 minus the R2, right? So I get a circle with a radius of R1 minus R2, and then I get another green side circle with the O and O prime as my as my as my diameter, right? And that intersect at the point of P, right? I get that point P, and after that, there everything it's just the same as before. Okay, so let me give everyone 1 minute. So that's the first problem for today. Okay, the how to draw the tangent line to the two circles, not just one, right? So last time we did the tangent line for one circle. Now I'm going to make an extension for two circles. Everyone's good? All right, so let's for the next problem. So let's see. Next problem, I want to do the so let's see. So here's some other problem. Okay. So here's a question. All right. Given three known collinear points A, B, and C. What's the locus of points, which is 1 centimeter from A, and equidistance from B and C. Okay, so let's see. Try to understand what's the problem. What does that mean? Okay, so I want to get the following. Okay, I want to get the following. Okay, basically, where everyone understand that. So let's say we get 3 points. So let's say suppose I give 3 points. So here is the A. All right, and then I get maybe B here or maybe C here. Right. Okay, I only get the nucleus of the points. Okay, what does that mean? The nucleus of the point. Nucleus of the point just means that it's all of the points satisfy the condition, right? And then the points can form something. Sometimes maybe a curve, sometimes maybe just the individual points, right? I want to see what kind of points, right? If we form them together, so nucleus of the point just means it's a connection of all of the points satisfying the condition. Okay, so let me call that P. And I want the P here. So what does that mean? The P should be the following. P, suppose it's a P here. The distance from A to P, that's 1 centimeter. Okay, that's one thing. And another thing is that the P has the same distance to B and C. So the distance from P to B and the distance from P to C, the two of them are the same. Everyone understand my question? All right. So I want to find all of the point P. Okay, P has the following two properties. The first one is the PA is equal to 1 centimeter. So the two properties. Okay, one is that the AP is equal to 1 centimeter. Secondly, PB must be equal to PC. All right. So you get so ABC are given. I want to find all of such P's, right? That's also called the construction. in geometric construction. So how can we do that then? Okay, give everyone 20 seconds. All right. So first of all, I'm going to give you a condition here. I think this is a theorem we introduced earlier in the 06 or 07. Maybe 06 or 07. I forget exactly. Maybe let's see. I think maybe in the 07 and geometry. Because when we proved that by using congruent triangle. So if I have PA equals if I have PB, let's see. If I have PB equals the PC, if and only if P is a point on the perpendicular bisector. Perpendicular bisector of BC. Okay, why? Let me take a note. So if I have a BC is here, right? So let's say here is a B and here is a C. Okay, if I have a P with equal distance to B and C, that means P must be from the perpendicular bisector. Okay, any point from the perpendicular bisector have the condition of the equal distance to B and C, and vice versa. Why? How do you prove that? Well, you can just prove by using the congruent triangles, right? The two triangles are congruent. So you got this triangle, right? And then the other triangle. The two triangles are congruent triangles. So you get the congruent triangles, and then we are done, right? So that is the result that we have in the previous semester, right? We can get that, and now we're going to use this. So what can we do here? First of all, I want the P to have equal distance to B and C. So what can I do is that I'm going to connect this, and then I'm going to draw the perpendicular bisector. So draw a perpendicular bisector, right? So the first step, we are going to draw the perpendicular bisector of BC, right? We draw a perpendicular bisector. So let me use the rate 9. So that's a rate thing. We just finished that, right? And how about second condition? Where that's the second condition here. The first condition is that I just need to make sure this is AP is equal to 1 centimeter. Well, that's easy. That just means that all of the P should be on the circle, right? So I'm going to draw a circle. So let's see. So I'm going to draw a circle, right? So that will be the. So I'm going to draw a circle like with a radius of 1, right? So this is a circle of radius 1 centimeter, right? With the center at A. And then the two objects will intersect either at 1 point or 2 points or 0 points. So P will be the intersection points, right? So what are the P? The nucleus of the P. The nucleus of the P will be the intersection points of the green circle and the rate 9. So the answer may be sometime maybe 1 point, sometime maybe 2 points, sometime maybe 0 points, right? So the answer maybe 0 points or 1 point or maybe 2 points, depending on the relative positions of A, B, and C. So we are done for this. Okay. I'm gonna give everyone a minute. Okay. So that's the problem to find all of the possible P's. Right? For each condition, you just try to draw, what, if I want to satisfy the first condition, what are the P? Right? The first condition basically says that P must be on the circle, a radius 1 centimeter and center at A. The second condition means that P must be on the perpendicular bisector of BC, right? And then we have the two things, we want to intersect them, right? Sometimes there may be no intersection, depending on the position of the A, B, and C. Everyone's good? Excellent. Now I'm going to give you, what's the next problem? Let's try some other problems. Okay, the next problem is the, so let's say, suppose, given a circle and a segment. Segment just means 9 segment with length k. Okay. All I want is that I want to inscribe in the circle Okay, so let me explain the problem here. Let me explain that. So I give you two things. One is a circle. So first of all, we get a circle. All right. And another one is the is a 9 segment with a length of k. So this is a 9 segment with a length of k. And k is not too big. Usually k is smaller than the diameter. Okay, because otherwise there's no solution. Okay, so I give you a circle and I give you a 9 segment of length k. Now, all I want is that I wanted to draw, inscribe the triangle. But that triangle has to be an isosceles triangle. And the base of the isosceles triangle is a given length of k. Okay, does that make sense? So what I want, okay, let me try to give you the idea. So the idea is that first of all, I want to get the length of the BC. I hope this is equal to k. That's okay. This is easy to get. Why this is easy? You can just go from, pick any point, and that's your center of B, right? Pick a point B. So first you pick a point of B on the circle, right? And then you draw the first step, second step, you draw a circle. You draw a circle with radius, with the radius of k. Wait, why? Well, because I want to get the base to be the k, so you can get a circle, something like that, right? So this is a circle like this. Can you see that? So the circle have the excuse me, like that. So so B is your center, right? B is your center, right? The radius is a k, so you can have the two intersections, but maybe just pick one of the points, right? So I get a C here, right? Everything's okay, right? So I get a C here. So I can get the BC very easy with a given length. But the point is that how could I get the A? Where is the 8 here? A must be, if I have A here, and A, B, C must be isosceles triangle. So where's my A? Suppose A is here, and I want an isosceles triangle. So all I want is that I get this one and that one to be the same. So how could I get the point of A? How could I get the point of A? Where to get the point of A? Where that's a condition of the AB. So I need a condition of the AB equals the AC. But what does that mean? This means A is on the perpendicular bisector. Perpendicular bisector of the BC. Okay, that's very easy. So that means I'm going to use a green one. Green one will be the perpendicular bisector. And I'm done. So basically, the A, we have two choices of A, right? A could be on the top, or A could be on the other side. So another A could be here. So we have two different ways to draw such a triangle. Does it make sense? A could be in this side, or could be in the other side. And the two triangles are not the congruent triangles. So here is another way you can draw the A, B, and C. Can you see that? I have two different non-congruent triangles of A, B, C. So that the triangle is an isosceles triangle, and then the base of the isosceles triangle is a given length of K. And then we are done for this question. Okay, just give everyone some time. It's a little bit hard. Okay, next question. So let's say, so given again, I'm going to given the segments with names R and S. Okay, and suppose R is smaller than S. Okay, I want to construct the following. Construct a right triangle. Construct a right triangle of the ABC with angle C to be 90 degree. And AC is R and AB is S. Okay, so let's see. Let's try to understand the question. All right, so what I get here is that I only given, so suppose R is here and S is here. Suppose the two names are given, R and S are given. What I want the following, okay? I want a right triangle. I want to get a right triangle of the A, B, and the C, A, B, and C, such that C is 90 degree, AC is R here. I only have R here. I only have S is here. Does it make sense? So you are given the two names, R and S, and I want you to get a right triangle so that the hypotenuse is S and the one of the leg is equal to R. And this triangle is a right triangle. Okay, how can you draw the picture? It should be pretty easy. Okay, give everyone 20 seconds. You should be, this should be very standard. So first of all, when we have the right triangle, right? When we have the right triangle, usually you need to consider the diameter of a circle, right? Because if you have the if AB is the diameter of the circle, then C is a right angle there, right? So we can get that, all right? And so you are going to first of all, the first step is that you are going to, let's go from here. I'm going to draw a circle with S as the diameter. All right, so that's my first step, right? So this is a circle with the segment with the length S as the diameter, right? So I know that C must be somewhere on the circle. But on the other hand, the distance of AC is equal to R. So that means I can draw another circle, right? C must be on the circle of the radius R from A here. So I'm going to draw a different circle. Another circle will be somewhere here. So I'm going to go from here. I can draw a circle in this way. So this is a circle of radius R. Can you see that? And now I'm done. So that will be my point of C. Can you see that? Why this is my point of C? Because I have two conditions, right? The first condition is that you want the angle C to be 90 degrees. So I just want to make sure that I draw a circle with S as a diameter, right? That's one thing. And another thing is that you want the distance of AC equals R. Okay, I just draw a circle with the radius of R. So I can have this, right? So I can have connect that and connect this, and I'm done. So this is my A, and this is my B here. Can you see that? So we have all of the three conditions are there, right? Why this is R? Because this is just a radius, right? The radius of the circle. So that means AC is equal to R. And why this is a right triangle? Because of the diameter, right? AC is the diameter of the circle. And then we are done, right? Again, I didn't write down the detail because it's too detailed. You don't have to write down the whole thing. All you need to do is you just need to know, how to do the construction. Okay. We don't have much time left, and let me give you one more problem for today. Okay. So here's the next problem. All right. So let's say given the 9 segment of AB. Okay. And all I want is that I want to find the nucleus of point P such that the angle of APB equals a given angle, equals the angle of alpha. Let's say given the 9 segment AB and the angle alpha, okay, the alpha angle. And so what I want is that I want the, let's see. So suppose I have the AB here. Let's move down a little bit. Okay, so here is, assume that this is my AB here. And now I have an angle here. So this is angle alpha, All right, everyone knows that. The two things are given. So one is the 9 segment of AB. The other one is the angle of alpha. Okay, what I want is that I want to find all of the points P, right? The nucleus of the points P, such that the APB is equal to a given angle. Okay, let's see. So it might be somewhere here, right? So that's the P here. So APB, this angle is equal to the alpha, right? This is the alpha angle. But keep that in mind. In this case, there are lots of P's satisfy the same condition. Okay, why? There may be, here's the P here. There may be another P somewhere, Okay, maybe another P here. Why this P is also fine, where as long as you can form a angle of alpha here, that should be fine. And here maybe another point of P in this way. This may be also good, right? So it's a P here. Can you see that? So there are many, many P's satisfy the condition. And not only above that, it's also below the AB. So what is this? Okay, give everyone a minute. Okay, I'm gonna get some water. Give me a second. All right, I get my alarm, so we don't have much time. I can just give you a few more minutes. Let's see how to do it. Well, let me give a suggestion. So the key idea for this is that we use the inscribed angle theorem, right? So some time ago we have the theorem, right? The theorem says that if I can have a circle, right, and suppose this is my AB, right, and if this is an alpha angle, right, if this is a P is alpha, how about the other point here? If I pick any other point Q, right? So let's see. The question is that what happened for this angle? Okay, everyone understand my question? Suppose I give you a circle here, and then APB has the angle alpha. How about the other point Q? Q is also from the circle, but from the same side. And then this angle here is also equal to alpha. Why? Because this angle is equal to half of the circle, right? So this is half of the arc, right? QP and angle Q, right? So basically, the nucleus of the point will be something like a circle, a part of a circle. So where's that? Where you will get something like that one, all of the points. So all of the points over that arc will satisfy the condition. All right. And not only that, this is just above the AB, and you can also do the symmetry for the under for below the AB. So you can actually have another part here. I try to draw the picture, something like that one, like this. So all of those points will satisfy the condition, right? You can have the P here like that. That also give you the alpha and then also give you that alpha. So that's the idea here. Anyway, we don't have time to finish this, and next time I'm going to finish that. So the question is that how to draw the two circles, right? Your points will be the rate curves, right? You have a big circle, big arc above AB, and also you have another big arc below the AB. They are symmetric. So how do I get that? Right, we're going to finish that next time. Okay, so that's all. Okay. Okay. All right, I'm going to finish it. Okay, see you next time.
Bye. Thank you.
Yeah.
Thank you.
Yeah, bye.
Oh, thank